pivot is a control that's been iconic for the Windows Phone platform, and we brought it across all devices. And we've thought really hard on how do we make sure that the pivot works great on any screen size, on any device. So some of the things we've done, for example, on desktop, you can see here that as soon as you make the pivot large and all the pivots can fit on the same page, it kind of looks like a tab. As soon as you go down to a smaller screen size, well, not all pivots fit. It kind of goes to the iconic experience of the pivot. We can go scroll between the pivots. As soon as you start using a mouse, you can get the arrow show up, and you can start using the control with your mouse, etc. We've also done a lot of work to make sure that we converge the platforms in a way that is well done for your existing applications. So for example, in this case, we have the datetime control that exists on Windows Phone 8.1 and a datetime control that exists on Windows 8.1. Now these controls are similar, but they work a bit differently, and we want to make sure that we find the right solution, that they work across all different platforms, and we want to make sure that the applications that you've already written can also be moved over to the Windows 10 platform very easily, simply by recompiling. So we converge a lot of these controls to create an experience that works across all the different devices. It supports all the different APIs that you're already used to, and it just works great. So all you have to do is just focus on building these applications that are beautiful and then have amazing experiences rather than focusing on how do I handle input, how do I handle screen size, etc. Second thing we've done is enabled you to do very beautiful responsive designs really easily with the platform. How many of you have used the Visual State Manager before in XAML? Cool. So for those that haven't used, the Visual State Manager it gives you the capability to have many different states you can switch between depending on many different events. So you can go to your code behind, you can switch between different styles for different views in your application. Currently, to use the Visual State Manager, you have to use object animation using keyframes just so you can do a specific discrete change in the UI. And it's not always easy to do that. And if you want to switch between states, you have to use C# or the code behind to do that switch. You can't do everything through XAML. And as Joe showed today, we've added the ability to do triggers. So for example, the adaptive trigger here allows you to automatically switch to this state if the minimum width of the window goes above 720 pixels. And you can have many of these states, they can automatically switch their state without you even having to go to the code to do that. And we've also added the ability to do setters very easily. You can now simply just reference a control using their name and just their property and setting a value for that property. You no longer have to use these keyframes and have this complicated long visual states just so you can change a very simple opacity or visual state. But this is just a simple example. We've also added the ability for you to create your own extensible triggers that can do anything on the platform. You can create an extensible trigger that can detect what device you're running on or detect what input you're running on. In this case, there's an input type trigger that we've created that allows you to bind to an activity list depending on what input you're using, if you're using pen or touch, and then set some specific setters. Now I have a quick demo that I want to show you of how this looks like. So if we switch over to the demo machine. Now, how many of you are cat people? How many of you love cats? Not many, okay. How many love dogs? Yeah, the majority of people. What about the rest of you guys? You have to do one or the other. You can't do both. You just can't do both. So I have a little application I want to show you. If we can just switch to input 2. So I have this application that I'm a dog person, so apologies for you cat people. There's not that many of you, so I don't feel that bad. So if we run this application, you'll see a little cool game that I've created. I call this Peekaboo. So it's a little dog, very cute, very sad. It's a sad dog. But as soon as I step in front of the machine, it goes to a happy dog, and I can do Peekaboo, Peekaboo. It's a very fun game to play. Now, and I did this with extensible triggers. So if you look at the XAML page for this application, you'll see here I have a simple image, and I've just set the source to sad.jpg. You can imagine that's the sad image. And I've created this new state called the happy. If you notice the state trigger, I have this peak trigger that I've created. And I'll show you the code what this looks like. And I've set the mode to face detected. So every time a face is detected, it switches to this state. And in the setters, all I do is simply just set the happy page to the happy.jpg. Very simple. Now, in the ability that allows me to do this is we have a new capability in the camera APIs. We have a new filter that allows you to simply detect when the face is in the view of the camera. You can detect how many faces, where they are. It's very easy to use. So I took advantage of that. So here is my implementation of the pick trigger. You can see I'm extending state trigger base. This is how you create your own extensible triggers. And here's the mode that I showed you, the phase detected mode. I just create a simple property just like you have in your other applications. And I initialize some parameters. I initialize the phase detection. It's just made 20 lines of code. And every time a face is detected or not detected, I simply check to see what mode I'm in. So if it's phase detected and the detected faces count is more than 0, I simply set this state to active. And that will set that active and apply all my setters. So it's just a very cool example to see how this actually works. I'm going to run it one more time because it's fun to play. Peekaboo! Yay, OK, it works. Now, this has been a huge interest from the community. Morten Nielsen, one of the MVPs in the program, has actually created many of these extensible triggers that you guys should check out. They have triggers for detecting what platform you're on, what input you're on, and many different types of triggers that you can extend, and they're all on GitHub. So I encourage you to go ahead and check them out. The final thing that I want to talk about for XAML is that we've made the platform very highly tailored. So you can actually just take control of the platform and you have access to all these APIs that we are using for you to create this rich controls and rich extensible views so they can be adaptive to the platform. You don't have to use the same controls that we're using. If you want to create a control, you have a great idea, use that, and you can still have access to all the APIs to detect input, to detect what device you're running on and size, et cetera. One of the cool things that we have is the XAML view, which allows you to have different views, different XAML pages for different device, but still continue using the same code behind, so you don't have to repeat code between different pages. And you can simply do that just by putting a XAML page in a different folder with a right naming convention. There's many other things we've done to the platform, and if you're interested in learning more about this, we have about 20 different sessions that we did at Build about a month ago in San Francisco that goes through many of these features. Some of my favorite ones are, for example, we've added change notification dependency properties. If you wanted to do this in the past, you had to use iNotify to extend a specific class and you actually get all these events, and it was just a lot of work. Now you can just simply get a simple callback. We've added the ability to do perspective transform 3D. So you can do really rich 3D animations and 3D effects simply by just applying this perspective transform on your grids or borders, et cetera. Now, because applications are windowed, they have Chrome, and you have access to this Chrome to modify it any way you want. You can modify the color, modify the buttons. You can even create your own XAML to go inside the Chrome to replace the default view. And finally, as Joe showed this morning, we have drag and drop. And it's very simple to use just by simply adding a simple event to handle the drag from any other application or even from the desktop. There's many, many more that you can use. And I definitely encourage you to check it out. And later on today, we have a Q&A. So if you're interested in learning more about this, you can definitely ask us at the end of the day. Now, I want to talk about performance a bit. Now, XAML, you can write many beautiful applications, and the application will be great. But unless your application is performant, none of your users are going to use your application. So we've done a lot of work in the platform to make sure that your applications are performant and easy for you to use. One of the best things we've done, I think, in my opinion, is we're actually using the exact same XAML in Windows 10 ourselves for first-party applications. Jeff showed this morning that Microsoft Edge is actually built as a universal Windows application using the exact same APIs and controls that you have access to. The Start menu, for example, or many of the first-party applications are written with the exact same SDK that you're using today. This allows us to make sure that the platform is bug-free, that it's performant, that you get the right performance out of there, and you don't have to worry about somebody else not using the platform. Simply by just recompiling your application from Windows 8.1 to Windows 10, you get a huge resource benefit. For example, just by recompiling a simple application or even a complicated application, you can get a memory almost by half, memory resource down almost by half. Even the startup of your application can increase drastically just by recompiling, making no other changes to your application. And we have some graphs of application that we've tested to see how this works. Besides that, we've also made many improvements and additions to the platform that allow you to make your application more performant. Some of those things is improvements in the binding system. Now, how many of you use binding in XAML? Probably the majority of you. How many of you love the performance that you get out of binding in XAML? Oh, you got one person. Hey, good job. So you can ignore this part, but not many people love the performance of binding. Binding is an iconic feature of XAML, but it's not that performance because you use a reflection, and if you have a lot of bindings, it just takes a lot of time out of your resources. We've thought really hard of how to improve on this, and we've came up with compile binding, which allows you to specify a data type at compile time, so the compiler knows exactly what you're binding to, so you don't have to use reflection. And the performance benefit you get of this is almost as if you weren't using binding. And it's amazing to use, so I can definitely encourage you to check it out and just use it in your applications. Second thing we've done is we've introduced progressive rendering, or the ability for you to set priorities to specific elements in your list item templates. So if you have a very huge templates and you have a lot of items, you can specify the priority of how elements are loading. So that way the user can get a visual feedback of items loading without having to wait for everything to load first. And they can start using your application sooner. And not just that, we've also added the ability for you to use deferred loading. So that you can actually defer a whole instantiation of an element tree in your application. So if something's off screen or something the user doesn't need to use immediately, you can load that later on so the user can start using the application a lot sooner than having to wait for everything to load first at the beginning. You can simply just do that by setting a defer load strategy equals to lazy. Make sure you remember that. I'll ask you that later in a quiz. And the last thing that we've done improvements on is around the tools. We've improved the tools a lot to allow you to do very quick development and make sure you can profile your applications very easily to make sure they're performant. So I can talk about quickly about some of the things we've done in Visual Studio to improve your XAML and your applications. First thing we've done is we've improved the XAML language services. In Visual Studio 2013, the XAML editor was actually binded to the designer. So if the designer crashed, you had to kind of wait, and you were kind of stuck not being able to write code. We've actually decoupled the XAML editor now from the designer, so you can immediately start writing code and not having to wait for the designer to load. We've also built it on top of Roslyn. So we've added some of the awesome, cool features that you have for example, in the C# editor, where you can do very cool things. Some of my favorite things I actually want to show you. So if we switch over to the demo machine, I want to show you a very quick feature that I really like. So here's the same application I showed you. Now, this is not one of the features that we just added, but it's something that's been long coming, and I love it. I just want to show you this. I'm sure you already know this. But you can now use touch in the editor. Isn't that amazing? I thought it was cool, yeah. However, one of my favorite features that we just added in XAML, let's say you're adding a button and you want to add a click handler. Now if I want to add this click handler, I have to go back to my code behind and find where this click handler is. But we've added the ability for actually to do peak definition and then use C# directly within your XAML editor. This just saves so much time. You don't have to even open up your C# page to do this. Let's switch back over to slides. The second thing we've added is the ability for you to have design modes. Now, I've said this many times, and we've said this throughout this presentation, is Windows 10 applications run across many different devices, from the small ones to the big ones. And you want to be able to quickly be able to switch between devices and see how your application looks like. Not all of you have a Service Hub, I imagine. So I don't have a Service Hub. So if you want to see what the application will look like on Service Hub for your customers, you will need to be able to see how that looks like. So we've added the ability to do design modes. And I'll show you that in a second. Another thing we've added is the ability for you to inspect the visual XAML tree while the application is running, so you can actually modify some properties and see what the tree looks like, and maybe you have some margins errors, and easily find elements within your tree, which is really cool, and I will show you that in a second as well. And the final thing that I want to show you is the profiling tools. I mentioned profiling tools before. They're now, by default, start up when your application starts, and you can easily check how much CPU you're using, how much memory you're using. You can get a snapshot of the heap, and you can see how much each line of code is running and how much time it requires. You can actually optimize your code very easily. So I'm going to run through some of these features in the interior design application that we showed this morning, that Joe showed this morning. So if we switch over to code one more time, here you can see the design surface that we have. And here is the same application you saw. Notice here on top of the corner, I have it set to 13.3-inch desktop. If I switch this over actually now to phone, for example, you can see that it immediately switches over to that screen size, to that DPI level, so you can easily edit your application and see what it will look like to that. We also have the Surface Hub. Here you can see that all the UI is now smaller, the resolution has increased, and it just looks much bigger. And also the Xbox and IoT device, all these devices are available right now from the designer. You can get this on any version of Visual Studio, it just exists, even in the free one. Now, if I run this application, I can show you the live visual tree inspector. Here it is. So I didn't write this application. So if I, for example, if I want to see where a specific element is, oops. If I want to see what a specific element is, usually I would have to go dig through the code and figure out where the specific image is so I can change it. Now if you use the live visual tree that starts up with Visual Studio when you run your application, you can see here I can simply enable a selection mode. And as I select elements in my tree, you can see I see all my XAML elements. Let me snap this real quick. As I select elements, you'll see things start to light up. You can see the layout route. I can see with the hamburger button. I can edit that. Like, for example, I can also do selection. So if I want to change the simple image, you'll see as I focus over a specific element, I get this little border around it. I can select this image. And I can simply, just by finding this image in the tree, if I right-click and view source, I can find this image exactly where it is in the source, and I can edit it right there. Before, this would have taken me at least 15 minutes just so I can find a simple image where it is. And now I can just simply select it. And not just that, I can actually see all the properties of this image. So I have the Live Property Explorer right here in the bottom, and I can see all the properties that this image is. I can change the properties here. Actually, I want to show you this, what this looks like on a template. So if I go back to Organize, let's say I want to change the size of the text here in the template for people that don't see that well. I want to make it really big. So I can simply select that text, go back here to the font size. I can see it's 10 right now. Change it back to 40. And I go back to the application. I can see what that looks like with 40 font size. And I think I'm gonna leave it like this. I feel I'm very good at design. I think this looks very beautiful. What do you guys think? Yeah? Now, the final thing I want to show you is the diagnostic tools. You can see the diagnostic tools are running here on the side as the application is running, and allow me to diagnose the application really easily. You can see I'm using about almost 45 megabytes of memory. You can see the CPU utilization is almost 0. If I do something big here, for example, I try to load a sketch that we have, and I can hit a breakpoint. And I've set this breakpoint before. The cool thing here is, if you see in the memory usage dialog down here, I can take a snapshot of the heap and see what the heap looks like. I can see how many objects there are. I can actually dig in through these objects and see if I have a memory leak somewhere. If I skip over a specific line of code, I can see how long that line of code took. So it took about 8 milliseconds for that line of code to execute. I get the same thing here in line within the code. You can see here it took about less than 29 milliseconds to execute this line of code. And just you get this really rich information about the lifecycle and your application debugging. Now I can also take another snapshot and I can compare objects from one line to the other line. It's very easy to now find memory leaks and find processes that take too much resources from your application. You can make sure that you don't use too much battery, you don't use too much memory or too much CPU time. Let's go back to slides. What do you guys think about these features? Good? Now, besides Visual Studio, we've also done many improvements to Blend. How many of you have used Blend? How many of you love using Blend? Some of you, great. No, I love using Blend. Blend is an amazing tool. I mean, just for making animations and having the whole timeline for making really cool animations and having your visual states done really nicely, it's amazing. However, it hasn't been a great tool for developers. If you want to write just simple code to edit something in Blend, it hasn't been that easy before. And a lot of cases, sometimes when you switch between Blend and Visual Studio, you get this ghost pop-up saying you've changed something and you don't know what you changed, and you just want to like hurt the computer because you don't know why that's happening. Now we've fixed a lot of that. We've actually rebuilt Blend now all the way from the ground using Visual Studio technologies. So the same editors that run in Visual Studio run in Blend now. So you can get the rich editing capabilities that you have in Visual Studio. You can actually start with Blend, create a new project, do your editing that you need to do, add some design time data, and run the application all the way from Blend without even switching to Visual Studio. And everything syncs back and forth between Visual Studio and Blend. And we've talked about the device family extension SDKs. Now these are, for those that don't know, these extension SDKs give you the capabilities for a specific device family that are not available in the core set of APIs of Windows 10. For example, I showed the IoT board, the Raspberry Pi 2 this morning, and has access to the GPIO pins. Now, not all devices have access to GPIO pins because the desktop doesn't have GPIO pins. So we've added an extension SDK for IoT that gives you access to this many APIs. The cool thing here is that you can actually now just check for a specific feature, a specific contract that a device might have, rather than simply checking to see if you're running on an IoT board. The idea here is GPIO could exist on a desktop device, and you don't want to exclude that device from your code. So if you want to just check to see if a specific feature exists and handle that in your code, you can do that by using the API information is type present API that we've created. That simply allows you to run code only if that device supports that specific feature. And it's very easy to use. Now, I've talked a lot about performance, talked about the tools, but I haven't talked much of the new APIs we've added. Before in Windows 8.1 and Windows Phone 8.1, we've had many different models for the app model and the way the lifecycle has been handled. In some devices, pressing the back button closes the application. In some devices, it simply suspends it. We've now unified that across all devices. So all the way from the small device to the Raspberry Pi 2 to desktop, the app lifecycle management is the same. The app model handles everything, all the way from the moment you installed it, the way you manage resources, how you do updates, and hopefully to the moment where you don't uninstall your application. Now, many people ask, well, I already have a Windows Phone Silverlight application I've written. Will that run on Windows 10 devices? And the answer is, it will run on the device that it was meant to run on. So if you've written a Windows Phone Silverlight application for a Windows Phone, it will continue running on a Windows Phone running Windows 10. It will not run on a Windows desktop machine because it hasn't been built for that device. Same thing with the modern application in Windows 8.1. They will continue running on Windows 10 desktop devices. However, if you write a Windows 10 application, those applications actually run across all the Windows 10 devices, and we're going to make sure that works. And with having all these applications running on many different devices, we've thought really hard on how do we handle multitasking. Some of these devices don't have many resources. Some of them have a lot of resources. So just one model does not work for all of them. In Windows 8.1, we had quotas. For example, if you have a background task, the minimum you could get processing for that background task is 2 seconds of CPU time every 15 minutes, which was not a lot. So if you have a desktop machine, why not get more? Because you do have those resources. You're not limited by battery, you're not limited by any other memory restraints. So we've redesigned the way that we handle multitasking on the platform. We were very smart about how much resources we give you. If a device can give you more resources, your background task can run more in the background, or you can handle more things. We've also added the ability for you to ask for more time. So if you're saving a file and you don't have enough time and the system's going to shut you down, you can say, hey, I need more time, and the system will decide how much time to give you. Or you can also ask the system to always keep your application running. And you can use this for things such as turn-by-turn navigation, et cetera. We've also added many new triggers to the platform that were not available before. One of the most asked triggers that we got from the community is the ability for an application to run its own background task. Believe it or not, that was not available before, but now it is. We've also added some triggers for many different new capabilities we added to the platform. So for example, we now have support for Bluetooth beacons. So if you're nearby a Bluetooth beacon that's advertising some kind of data, you can actually get that data. You can get a background test that wakes up every time there's a beacon near your application. So we've added many of these triggers. And we also unified the navigation model. Now just simply pressing the back button on an application will simply do the exact same thing on all the different devices. Pressing back on phone is no different than pressing back on Windows or pressing back on Xbox. So you don't have to worry about the different app lifecycle states that you might have. Everything's the same now. Now, one of my new favorite features in the app model that we've added is the ability for applications to communicate very easily from one another. Before, if you wanted to talk from one application to another application, you were able to use protocol activation to simply call into another application. This other application will simply replace the running application and just do some processing. There's no way from the calling application to go back, to call the application to go back to the calling application. We now added the ability for you to do foreground-to-foreground communication by simply using protocol activation, but then asking for results back. So you can call in, you can use a protocol activation, and you can, for example, now pass some data to an application. This application can replace your application, do some processing, but then call you back and return some results back to your application. So you no longer have to do some crazy communication between applications and talk to the developers how to handle this. You can also pass in things such as files. You can pass in whole files from one application to another application, and they can be passed back and forth. My favorite feature is actually being able to do the same thing with background tasks. So your application can actually talk to different applications' background tasks. So you can think of this as having a web service just running locally on the system. And actually, I want to show you this in a demo. So let's go ahead and switch to the demo machine. There it is. So one example I want to give is, imagine having a social application that, for example, it lives on the system, it keeps track of the user already logged in, has all its friends, the status, updates, everything. You, as a developer, can write an application that takes advantage of that social application's background service to simply get information about the user that's already logged in. You don't have to know how the API for that application works to their web service. You can simply just talk to the application that already handles that on the system. Now, I have a very simplified demo here. Let me go ahead and run it real quick. All it does is actually very complicated. I don't expect you to understand it immediately, but if you press the ping button, it responds with pawn. It blows your mind. It's crazy. I kid, of course. But simply what this does is actually, when I press the ping button, my application calls into a background service from a different application that I didn't write and actually gets the pawn back that way. The other application doesn't start up. It actually just uses the background service to get that communication back. If you look at the code for how this is implemented, it's actually very simple. Here's the solution. I'll show you that real quick. You can see here that we have an app service. That's the service, the application that somebody else has written, and they have a background task that they're using. And then my application is going to access that background service. In my code, here, all I do is simply create a new app service connection, and I specify an app service name and package family name. This is something that the application that the other developer has written will give me access to by giving me this information. Once I have this information, I can simply send value set messages back to the background service and wait for a response by sending send message async. The background service, the other developers that they have written, simply what it does is actually waits for this connection. So here you can see I'm actually registering an app service. I create an app service from the trigger details, and I register for every time I get a request from different applications running on the system. Once I get a request, I can simply open up the message and read the message. In this case, I send ping. Once I expect the ping, I can create a new value set, add that to my response, and simply send the response back to the calling application. And once I'm done, I simply just close the deferral. And you can see that applications can now be very rich in the way they communicate to each other. Now, I want to talk a little bit about tiles. Live tiles have been very important to the platform. It has been kind of a unique features that we've had on the Windows platform. And we've thought really hard on how do we unify that across many different devices. Cool thing to note is that the tiles that you see here are actually the exact same tile. They're the medium-sized tile on the platform. You can see they actually adapt very easily to the device size that they're on. You don't have to worry about making them look pretty. They just work. Now, some of the feedback we receive from developers is that the live tiles are great, they work great, but they want to have more controls about how they look or how they work. Currently, we have templates, many different templates that developers can choose from, but they're limited to only those templates. They can't create their own. So now in Windows 10, we've added the ability for you to actually create your own templates by using simple XML notation to identify your own UI, your own branding within live tiles. So you're not limited to the existing templates that already exist that still work actually on the platform. The same thing actually works on Toast templates. We've heard the exact same feedback on Toast templates for notifications, and we've added the same ability for you to create your own templates using simple XML notation. You can now actually also write Toast templates that have they have interactive content on them. So you can have, for example, a text box, or you can have a button that a user can press that doesn't even open your application. It simply just allows the user to interact with your application by using the notification and not lose focus of what they're already doing. And it's good to note that this feature actually uses the app-to-app service that I just mentioned previously. The final topic I want to talk is .NET Native. Now, I've mentioned many times that application will run on many different devices, and some of these devices don't have many resources. So we want to make sure that we get the best we can from the platform. And .NET Native allows us to actually compile the managed code that you're writing, your C# code, for example, down to native code, to native bytes. It uses the VC++ runtime to actually run this code, and it's no different than running any C++ code. It doesn't require the .NET runtime. The cool thing about this is if you just compile with .NET Native, your Windows 10 application, you get about 60% savings on CPU from cold start, or 40% from warm start. And you even get savings from memory of 30% when you run .NET Native. I want to show you one last thing, which is just how this looks like in Visual Studio. So if you switch over to the demo machine real quick, if I right-click on the project, for example, and go to Properties, you'll now see that we have, under the build tag, we have this checkbox that allows you to simply check to compile with .NET Native toolchain. You can simply just check this, and your application will not compile with .NET Native. It will take a little bit longer to compile because we do some optimizations, and we actually compile down to native code. So what we've done is, you can see now by default, it's not checked. But as soon as I go to release mode on my application, that checkbox finally gets checked. The idea here is, while you develop your application in debug mode, you can still get the quick debugging and deployment of your application, but then you want to test them in release mode, you can get the benefits of the performance improvements. And another thing to note here is that once you're ready to submit your application to the store, your application will has to be compiled down to .NET Native, and will be compiled down in the store and shipped out to all your customers. Let's switch back to the slides. So in summary, we're listening. All this stuff that I talked about is because we receive feedback. And we have the feedback application, Windows 10. We receive all this feedback through user voice, et cetera. So we encourage feedback from all the developers that they want to talk to us. In summary, I talked about how XAML does all the hard work for you. And we've done a lot of work to enable responsive design and for you to create custom applications. And we're using the exact same XAML controls and APIs that you're using right now. So you get the benefit of having a very performant platform. New Visual Studio features that we've added to Visual Studio 2015 allow you to create very easy responsive designs and very performant applications, and make sure that you can check the performance and do debugging on your application really easily. We've unified the app model across all Windows 10 devices, and we've added some awesome APIs such as the rich app-to-app communication. And finally, we've enabled you to compile your managed code down to native code so you can get the most performance out of the device that you can.